Good morning. So, good morning, students. Okay. So, all of you can see me. It's clear, right? Hmm? All of you can see me, right? Okay. Good morning. Okay. So, with respect to the last class, can anyone tell me the words what we have discussed in the last class? Just words you can send. Okay. Okay, Rakesh. So, what we have discussed in the last class? Just words. Okay, limiting reagent. Very good. So, we have discussed about the limiting reagent. Yes. So, that's what we have discussed in the last class. Now, what do you mean by limiting reagents? So, limiting reagents are nothing but these are the reactants. So, these are the reactants which will get consumed during a chemical reaction. So, what are limiting reagents? These are the reactants which will get consumed during a chemical reaction, right? So, due to that, since it will get consumed, so what it will do, it's going to decide what is the amount of product which has to be formed. Got my point? So what do you mean by limiting reagents? These are the chemicals which will get completely consumed during a chemical reaction. Okay? So since it will get consumed, so it's going to decide what is that amount of product will be formed in that reaction. So therefore, limiting reagent is going to decide the concentration of the product which will be formed during a reaction. Right? So that's where we have the limiting reagents. Then we have solved some of the problems. So we have solved some of the problems. So very important with respect to your examination point of view. Okay. So to solve the limiting reagents, problem based on the limiting reagent, what and all is required? We require balanced chemical equation. To solve the problems on limiting reagent, we require a balanced chemical equation. That's very important. Therefore, try to practice balancing the chemical equation. So without that, you cannot. Then another thing, if you observe, you should know atomic mass of the element. To solve the problems on limiting reagent, you should know atomic mass of the element so that you can calculate the molar mass. You can calculate the molar mass. So please remember, all these days, whatever problems we have solved, in all the cases we require atomic mass, then we have to calculate the molar mass, then only we can solve the problem. So therefore, practice at least up to 40 elements with their atomic number and atomic mass. Fine, that is one thing. Second thing is practice balancing the equation. Try to take many equations and try to balance that one. It's a very simple one. Okay, so that's what we have discussed in the last class, right? So then we were starting about solutions. We were starting about the solutions. Now when it comes to this topic, anyway, in detail about the solution, I am not going to discuss because same thing you are going to discuss in your second PU. Solution, same concept you are going to discuss in detail in second PU. Okay. So what I will do is briefly, before going to the concept, briefly I will tell what you mean by solution. As we know, yesterday we have discussed solution will be containing two components. One is solute and another one is solvent. So one is solute and another one is solvent. Okay. Dikshit Kumar. Okay. Fine. So that's where we have the solutions. Solute and solvent. Right? Now what do you mean by solute? Which will be of low concentration. And what will be solvent? Which will be of higher concentration. Solvent will be of higher concentration. Right? So that's what we have discussed in the last class. Fine. Now if I take a salt and if I add it to the water, now I am going to get solution, salt solution. If I am going to have glucose or sugar, I am adding it to the water, now I am getting sugar solution, where sugar will act as a solute and water will act as a solvent. Yes, Rohan, very good. So that's where solvent will be of higher concentration and solute will be of low concentration. Fine. So that's where we have the solution. Now, whichever will be of low one, whichever will be of low concentration. Now I am using the word concentration. Right? So now I am using the word concentration. So that means in case of the general English, concentration means focusing on something. Right? So it will be focusing on something. That's where it is called as concentration. But when it comes to chemistry, concentration will be related to what is the amount exactly present. See, being a science students, all of us, if you go and ask your mother who is preparing a limbu, sharbat or whatever it is a summer season, we will imagine, and have asked your mother to prepare a lemon juice. Now she has added a tea tablespoonful of sugar. Now if you ask your mother what is the concentration of sugar, she will become angry, right? Now I am simply kidding. Anyway, so there we are not bothered about the concentration, we are bothered about the taste. But when it comes to science, when it comes to chemistry, so whenever we are doing experiment, there can be either qualitative type or quantitative type. So qualitative means we are not bothered about the concentration, amount. We are talking about reaction. But when it comes to quantitative type, so that's where we have to focus even on the amount of reagent. So that's where when it comes to concentration, that we are talking about the amount of a particular element or a substance. So therefore, whenever we are talking about the solutions, we can talk about what is the concentration of that particular solution. So to express the concentration of a solution, we have to talk about what is that amount of solute and solvents are present. Got my point? So that's where we have to express it in terms of concentration. Right? So based on the requirement, there are different ways to express the concentration. So that's what we have discussed in the last class. So one way of expression is, that is percentage composition. Percentage composition or elements. Percentage elements. That is one thing. Right? Or percentage solute. That is another thing. So what I mean to tell here is, when I am talking about the concentration, we have different ways of expressing the concentration. So one is percentage composition, that we have discussed with related to different components of a particular element. That is one thing. So next we have mass percentage. We have mass percentage. That's where we are talking about what is that the mass of solute present in the solution. What is the mass of solute present in the solution, and we'll compare that one to the 100. We'll compare that one to the 100. So then mole fraction, yes, that will be mole fraction. Another one will be mole fraction. So when I am talking about mole fraction, so we are dealing with the number of moles. We are dealing with the number of moles. What is the number of moles of a solute present in that particular total mole fraction? That is total number of moles of solvent and solute. What is that exact amount of moles of solutes are present? Anyway, each one we are going to define, no need to worry. So that's where we have the mole fraction. Then comes the molarity. Then comes the molarity. And the last one is molality. And the last one is molality. So that's where we have the molarity and molality. So if you observe it carefully, mole fraction, molarity and molality. In all these cases we are dealing with the moles of the element. We are dealing with the moles of the element. So that means to understand this concept, you should know what you mean by mole. So what do you mean by mole? So these are the amount of substance which will be equals to the Avogadro's number. Which will be equals to the Avogadro's number. That's where we have the mole. So what do you mean by mole? It is nothing but amount of or number of element or a substance which will be equals to the Avogadro's number. So from where we got this Avogadro's number? So this Avogadro's number we got it from 12 gram of carbon 12 isotope will have same number of atoms. So that's where we have the mole. So to understand the molarity and molality, we have to know about moles. Okay? So now one by one we'll go. Percentage composition, no need to worry. Already we have discussed, and it is majorly applicable for a compound. So when it comes to the solution, we have to go with mass percentage. We have to go with mass percentage. Now, in that case, if I want to define mass percentage, it is the mass of solute. It is the mass of solute with respect to total mass of the solution. It is the mass of solute with respect to the total mass of the solution, which will be related to 100. That means if I want to write or if I want to find out mass percentage, I can use this particular equation where mass percentage is equal to mass of solute divided by total mass of solution. Total mass of solution multiplied by 100. Multiplied by 100. So what do you mean by mass percentage? It is nothing but mass of a given solute with respect to total mass of the solution multiplied by 100, or it's related to 100. So what I mean to tell here is, for these many mass, so this is the mass of the compound, how much will be for 100 gram? That's where it is related to percentage, since it is 100. So that's where we have the mass percentage. For example, I have X mass of I have X mass of solute A. Okay, so which was dissolved, X mass of A, which was dissolved in Y mass of solvent, Y mass of solvent. So what I mean to tell here is X mass of solute A was dissolved in Y mass of solvent B. Right? So we will imagine, it's a general one I am telling. So in that case, if I want to calculate mass percentage of solute, so then what I should do? Mass of solute I should take. That means X mass of solute divided by, now you should be careful. So total mass of solution, that means we should be knowing the mass of solvent and we should be knowing mass of solute. Together it will give the total mass of the solution. So therefore total mass of the solution is nothing but mass of A, that is X, plus mass of B, that is Y, multiplied by 100. Now if you see the denominator, so that's where mass of A and mass of B together will give the mass of solution. All of you have understood? So that's where we have the mass percentage. Okay? So that's where you will get the answer with respect to mass percentage. Any doubt? Any doubts in this? We will solve one problem. Okay? So if you don't have any doubt, we will solve one problem from this. So that's where total mass of solution means it is mass of solute and mass of solvent. Okay? So fine. In that case, you can write it down. Question, you can write it down. Solution. A solution is prepared by. A solution is prepared by adding 4 grams of NaCl, 4 grams of NaCl to 80 grams of water, 80 grams of water. Calculate the mass percentage of NaCl or resulting solution. Anything is fine. Can you do it? Calculate the mass percentage of NaCl. Can anyone tell me the answer? It's a very simple one. Anyone has calculated? So that is, what is mass percentage? So mass percentage means, I am talking about the answer now. Okay? So mass percentage means, okay, 33.33. 33. We will see. So mass percentage of NaCl means NaCl is equal to mass of NaCl divided by mass of solution into 100. Okay, so much answer you are getting. We will see. Into 100. Now, what is mass of NaCl? It It is 4 gram. I think you people have taken molar mass. Why to go for molar mass? Mass of NaCl is 4 gram divided by mass of solution. They have given mass of solution 80 gram they have given for water. Now we have to add 4 gram of NaCl. 80 gram plus 4 gram. So that is multiplied by 100. That is nothing but 4 gram divided by 84 gram into 100. So that is nothing but, yes, 4.76. No grams. No grams. It will be percentage. Okay? Because grams and grams will get cancelled. So it will be 4.76 percentage. 4.76 percentage. Okay? So Sneha, 4.76 gram we cannot write. We can simply write it as percentage. That is fine. Okay? So otherwise answer is absolutely correct. Yes, it should be 4.76. Okay? So I think earlier people had got different answer, might be because you have taken molar mass of NaCl and molar mass of water. No, I don't know what you people have done. So therefore you people have got different answers. Okay, Yagnesh, another question. Okay, we will solve it. So that's where we have the mass percentage of NaCl in water. Fine. So what is that? 4.76 percentage. All of you have understood? We will move to the next one. Okay. So next one. Calculate the, all of you can write it down. Calculate the mass percentage of resulting solution. Mass percentage of resulting solution when 2 grams of sodium hydroxide is dissolved in 40 grams of water. 40 grams of water. Find it out. 40 grams of water. So 2 grams of sodium hydroxide dissolved in 40 grams of water. Any one of you? 4.76. Even I have to see. Okay? So answer, we will solve it. Answer, mass percentage is equal to mass of sodium hydroxide divided by mass of water. So that is 40 gram plus mass of NaOH. So that is nothing but 2 grams, right? So multiplied by 100, which is equal to. So what is mass of sodium hydroxide? 2 grams. So divided by 40 plus 2, that is 42 grams, multiplied by 100. How much it will be? You should only tell me. Okay, yes, it should be 4.76. So it will be 4.76 percentage. It will be 4.76 percentage. Fine. But my point is, so that's where we have the equation to find the mass percentage of a given solution. So don't forget to write the percentage symbol. Okay. So that's where we have the problem. So we will move to the next one. Okay. Fine. So next one is related to mole fraction. Next one is related to mole fraction. Okay. So next one is related to mole fraction. So mole fraction, in the name itself it is there. It is related to moles. It is related to moles. So therefore, mole fraction of a solute in a solution. Mole fraction of a solute in a solution, or mole fraction of a solution will be equals to moles of solute, number of moles of solute divided by total number of moles of solution. So total number of moles of solution divided by total number of moles of solution. So that's where we have the mole fraction. No multiplied by 100, no. It's not mole fraction percentage. It is just a mole fraction. Since earlier we have got mass percentage, some students they will write mole fraction means mass of solute divided by total number of moles of solution multiplied by 100. No, multiplied by 100 is not there. Got my point? Now, by considering A as solute and B as solvent, okay? So therefore, now I can write mole fraction as, Na in the sense nu A divided by nu A plus nu B. So that's where we have the equation. Mole fraction where A is the solute and B is the solvent. And nu A is nothing but mole fraction of A or number of moles of A. Nu B is nothing but number of moles of B. So that's where we are going to find the mole fraction of a given solute in a solution. Fine. Same as that of the mass percentage. In case of the mass percentage, what we used to do? We used to consider total mass of the solution, and here we have to consider total number of moles of the solution. So when I am using total number of moles of solution, then I should consider number of moles of solute plus number of moles of solvent. So that's what it's written here. All of you have understood? Okay. Anyway, so related to this, in your textbook problems are not there. Any one problem we will solve. We will try to solve any one problem. Okay. Just for practice. Now, write down the question. Calculate the mole fraction. Calculate the mole fraction for a solution. Prepared by dissolving 4 grams of sodium hydroxide in 18 grams of water. 18 grams of water. So that's where we have the question. Sir, what is this, sir? We have simply given as that of the mass percentage. Yes, but you have to convert them into number of moles. Then only you can calculate it as mole fraction. Got my point? So now I will solve this one. Anyway, you can also solve. Okay? So 4 grams of NaOH in 18 grams of water. They have given in terms of mass. But we don't want mass. We want in terms of moles. So we have to find what is that number of moles 4 grams of NaOH corresponds to. So to give that answer, we should know what is the molar mass of NaOH. Okay? So therefore, first part it will be moles of NaOH. Calculation for moles of NaOH. Since 40 gram is the molar mass. Since 40 gram is the molar mass of NaOH, is the molar mass of NaOH. So therefore, the number of moles will be, we have an equation. Moles is equal to given mass divided by molar mass. All of you will agree? So that's where we have the equation. Now, how many number of moles will be there? Okay. So how many number of moles will be there? 4 gram divided by 40 gram. So that is nothing but 4 gram divided by 40 gram. How much it will be? 4 gram divided by 40 gram. It will be 0.1. Yes, it should be 0.1. 0.1 moles. 0.9. Someone has written 0.9. How come 0.9? Shankar, it cannot be 10 because 4 divided by 40 it is. Numerator is a small value, should be in fraction. So therefore 0.1 moles of NaOH given is. Now next one. Moles of water. It's very simple. Purposefully I have given. Moles of water to find out. What is the molar mass of water? Anyone? What is the molar mass of water? That is, water is nothing but H2O. 2 hydrogen, 1 oxygen. What is the molar mass of water? Okay, Shubhangi, it cannot be 0.1 gram. No. 0.1 gram. No, it should be moles. It's not mass. It is moles. Be careful about the unit. Okay, board is not clear. 1 minute. Now whether it's visible, board? Board is visible for all of you? Okay. So now moles of water, that means molar mass of, I have changed the marker, molar mass of water is 18 gram. So given mass is also 18 gram. Okay, no sir, means board is not clear. Okay, 1 minute. Now it's visible. Now whether it's visible? Can you tell me? I have changed the marker, don't worry. Okay. Okay, some students know, sir. We will see. Whoever is not saying it's not clear, I have changed the marker. We will see. Don't worry. So molar mass of water is 18 gram. Molar mass of water is, sir, switch on the light, okay. But if I switch on, it's becoming blur. Okay. So fine. So molar mass of water is 18 gram. So therefore, given mass of water corresponds to 1 mole. So therefore, water is 1 mole. Whatever given mass is corresponding to 1 mole of water. All of you will agree? So when it comes to sodium hydroxide, it is 0.1 moles. But when it comes to water, it is 1 mole. So we will see. Next, mole fraction. Mole fraction. Now you can see whether it's visible. Because question I can understand. I was using the same marker. Okay. So now you can see whether it is visible or not. Okay. So now therefore mole fraction is equal to moles of solute, that is sodium hydroxide. So we have got 0.1 moles. So what is that divided by? Divided by is nothing but 0.1 moles of sodium hydroxide plus 1 mole of water. 1 moles of water. 0.1 moles of sodium hydroxide divided by 0.1 moles of sodium hydroxide plus 1 mole of water. That is nothing but 0.1 mole divided by 1.1 mole. Okay. So 0.1 divided by 1.1. What will be the answer? Okay, even I will cross check. Even I don't know the answer. It should be 0.09 divided by 1.1. Yes, it should be 0.09. Okay, because some people have written 0.9, so even I got confused. It should be 0.09. So 0.09 mole fraction. 0.09 mole fraction. So that's where we have got the answer. Okay. So all of you have understood. So that's how we should calculate the mole fraction of a given solute in a given solvent. So to answer this one, what and all we should know? We should know molar mass. We should know molar mass. Okay. So then we should know, to calculate the molar mass, we should know atomic mass of those elements. Then next we should know how to find out the number of moles. Mole is equal to given mass divided by molar mass. So that's what we have done. Okay. So now if you have understood, we will move to the next one. If you have understood. Okay, you want to give another problem? Okay, fine. Sir, mole and mole gets cancelled. No, sir. Then how did you write the answer in moles? That's what I was telling, mole fraction. I think fraction I have not written. It is mole fraction. Okay, na? Very good question. But I was telling mole fraction, but I wrote it as moles. Yes. Now, next one. Calculate the mole fraction. Calculate the mole fraction of a solution prepared by dissolving 5.81 or 85 grams of NaCl in 1.8 grams of water. 1.8 grams of water. Can you do it? Calculate the mole fraction of a solution prepared by dissolving 5.85 gram of NaCl in 1.8 grams of water. Can you solve it? Okay. Sir, give another problem. Okay. Anyone? What is that symbol? Karna. Huh? Okay. So what is the answer? So now, I think some of you might started solving the question. So now I will start. I have given some time. Okay. So that you can answer. Mole fraction is equal to 1. We will see. Yes. Okay. So NaCl, all of us we know, molar mass is 58.5 gram because sodium is 23, chlorine is 35.5. If you add it, it will become 58.5 gram. That is the molar mass of NaCl. Now what is that given mass? Given mass is 5.85 gram. So divided by 58.5 gram. How much it will be? It will be 0.1 moles, right? It will be 0.1 moles. So that is with respect to the sodium chloride. So that is with respect to sodium chloride. 0.4. Okay, final answer. Now, when it comes to water, what is the molar mass of water? That is nothing but 18 gram. So therefore, number of moles will be 1.8 gram, that is given mass divided by molar mass. So that is also nothing but 0.1 moles. That is also nothing but 0.1 moles. All of you will agree? So we are giving last answer. Okay, mole fraction. Okay, fine. So what I mean to tell you is, see here, the given solution prepared by dissolving 5.85 gram of NaCl, right? So if I want to see 5.85 gram, how much moles of NaCl is there, we should know what is the molar mass. So molar mass of NaCl is 58.5 gram. Molar mass of NaCl is 58.5 gram. So therefore, given mass divided by molar mass. That is the equation, right? So then we are going to get the answer in terms of number of moles. So 5.85 divided by 58.5. So that is nothing but just like 1 by 10. So therefore 0.1 moles we have. Then water, 1.8 gram is the given mass and molar mass is 18 grams, same as that of the NaCl. So here also we have got the 0.1 moles. So therefore, mole fraction is equal to 0.1 moles of NaCl divided by 0.1 mole of NaCl plus 0.1 mole of water. Right? So that is nothing but 0.1 divided by 0.2. 0.1 divided by 0.2. Right? So that's how it's like 1 by 2. It's like 1 by 2. All of you will agree? It's like 1 by 2. So what is the answer we have got? What is that answer you people have got? Okay, 0.5. It should be 0.5. 0.5 mole fraction. 0.5 mole fraction. That's where we have got the answer. Okay, so 0.5 mole fraction, we have got the answer. Fine, all of you have understood. So shall we move to the next one? Okay, we will move to the next one, that is important one. Even for your competitive exams, they have asked about this, that is molarity. They have asked about even in competitive exams, so I will mention it as very important. So that is molarity. Okay, so symbol capital M, symbol will be capital M. Okay, so now when it comes to molarity, it is nothing but a ratio. Molarity is nothing but a ratio, or I can tell molarity is nothing but the number of moles of solute to the volume of solvent or volume of solution in liter. Volume of solution in liter. So what is molarity? It is the number of moles of solute to that of total volume of solution. So that's where we have the molarity. So I can mention molarity capital M is equal to number of moles of solute divided by number of moles of solute divided by volume of solution in liter. This one you should keep it in mind. In liter, volume of solution in liter. That's where we have the molarity. Volume of solution in liter. Okay, so that's where we have the molarity. Got my point? Shall we solve some problems? On this they will ask. For board it can be for 2 marks, or even in competitive exam they will ask. This equation you should know. So it is not volume of solvent, it is the volume of solution. Please remember. So that's where we have the molarity. Symbol is capital M. Number of moles of solute divided by volume of solution in liters. In liters. Okay? O-O-O-K-K-K, sir. Okay. So next one. Question. You can take down the question. Calculate the molarity of sodium hydroxide in the solution. Sodium hydroxide in the solution prepared by dissolving 10 grams of sodium hydroxide in water to get final volume. Because it's very much dependent on the volume. To get the final volume of 250 ml solution. To get the final volume of 250 ml solution. 500 ml. Right, yes. It should be 500 ml solution. Okay? 500 ml solution. Now if you observe this question properly, they have mentioned 10 gram of sodium hydroxide is dissolved in water To get the final volume of 500 ml, they are not mentioning as dissolved in 500 ml of water. That is quite common. You might have all heard about one story where a crow will be used to drink the water from a narrow vessel. How? By putting the stones into those small amount of water. Whenever it is adding the water into that vessel, what is happening? Water is rising up. Right? Water is rising up. Then at the end, a crow is going to drink that particular water. So that story all of you know, right? Same logic is applicable. Since molarity is very much dependent on the volume of the solution, for example, if you take in the beginning itself, listen to me carefully, if you take in the beginning itself 500 ml of water, and to that if you are adding 10 gram of sodium hydroxide, now naturally there will be slight increase in the volume. There will be slight increase in the volume. So therefore, to maintain the volume as 500 ml, so what they will do, they will first put the sodium hydroxide, then they will go on add the water in such a way that it should reach to the 500 ml mark in a measuring cylinder. All of you have understood? So that's what this sentence talks about. Okay? So now we will cross check. Oh, all of you have written it as 0.8 molar, might be correct. Okay? So we will calculate. So it is 500 ml. So molarity is equal to answer. Now I am going to talk about the answer. Molarity is equal to, oh okay, you people are getting how much? 0.8. No, we will see number of moles of solute divided by volume of solution in liter. Right? Now that's why I told in the beginning, the volume of solution in liter, many times I told. Right? So Likita, she is correct. Likita and Sahana, they are correct. Why I will tell you. Now, number of moles of solute given mass divided by molar mass. That means 10 gram divided by 40 gram. All of you will agree? 10 gram is the given mass and 40 gram is the molar mass of sodium hydroxide. So 10 gram divided by 40 gram. Volume of solution in liter, they have given 500 ml. I have to convert that one into liter. Sir, it's Likit. Okay, I'm really sorry, Appa. Yeah, it's Likit. Okay. So Likit, you are right. Okay. So volume of solution, I'm really sorry. In a hurry, I thought that it is Likita because we had a student with that name. So volume of solution in liter. Okay. So 500 ml is nothing but 0.5 liter. That's what I told repeatedly. If you see the equation, volume of solution in liter, not in ml. ml is milliliter. We have to convert whatever volume is given into liter. So therefore 10 gram divided by 40 gram divided by 0.5 liter. So why 10 gram divided by 40 gram? So given mass divided by molar mass. Right? So in that case it will become 0.25 moles in the numerator divided by 0.5 liters. Divided by 0.5 liters. Yes, now answer is 0.5 moles, 0.5 mole per liter, or we can simply write it as 0.5 molar, capital M. 0.5 molar. Even mole, some people they can write it as 0.5 mole per liter. That is also fine. Where they will not write E, but it's understood they are talking about mole. So 0.5 mole per liter or 0.5 molarity. don't forget to write the unit. Okay, don't forget to write the unit. Either you should write it as 0.5 moles per liter, or you should write it as 0.5 molar. That is capital M, not small m. Okay, so done. That's where we have the answer. That is 0.5 moles per liter. Okay, so we will solve another one on this. Okay, it's already. Okay, so what I will do is, I thought today we will finish it off. Okay, fine. So another 15 minutes, 10 to 15 minute session was there. So anyway, I'll stop here. So on Monday, if I am right, on Monday we are going to continue, or in the next class we are going to continue. So what you can do is, you can practice some more problems. Anyway, Monday we are going to, or next class we are going to continue. Sir, how to calculate only mass? Means with respect to what you are asking, Manjunath? Okay, thank you, Appa. Happy Teachers Day, thank you. So, Manjunath, you were asking something, how to calculate only mass? So, I am not getting, for what you are asking? Thank you, Appa. Thank you, Anju. Manjunath? Okay, mass percentage. That we discussed earlier. First itself we discussed how to calculate mass percentage. That was the first one. Okay? So anyway, don't worry. We will have this one in the next class. Okay? So don't worry. Even I have to talk about molarity. So once I finish this chapter, directly we'll start with the atomic structure or structure of atom. Okay na? So thank you for all your wishes and take care. Okay? So take care. Bye.